Hey everyone, welcome back to another Explainer. Today, we are embarking on a really fascinating journey. We're going to bridge the gap between those heavy theoretical computer science concepts and a battle-tested, real-world backend built with Kotlin and Ktor. We're literally peeling back the layers of software architecture to see exactly how pure business logic can be perfectly insulated from all the chaos of the outside world. But before we get into the theory, I've got to ask you something. What happens when you accidentally pass a checkpoint ID into a function where a user ID belongs? Well, if your system uses plain strings for both, the compiler is going to happily accept it. It looks totally fine on your screen. But at runtime, it's an absolute nightmare. The database throws a no such user error, your app crashes, and you spend hours chasing a ghost. This incredibly common, super relatable bug is exactly why strict architectural layers and typed identifiers exist. And today, we're going to see how to make bugs like this literally impossible to compile. Okay, let's dive right into this inside-out journey through our software onion. We'll start at the very center with the clean architecture core, then look at bulletproofing the domain, move outward to services and strategies, cross the persistence boundary, and finally reach the outer shell with DTOs in the API.
Section 1. The Clean Architecture Core. The Untouchable VIP section.
So in clean architecture, the absolute rules of your business live right in the dead center. This is the untouchable VIP section of your app. This pure domain layer is wrapped by a really thin, replaceable shell of databases, HTTP routing, JSON parsers, and frameworks. Why design it this way? Because it vigorously protects your core logic. If tomorrow you wake up and decide to swap out SQLite for Postgres database or Ktor for Spring Boot, you can do all of that without touching a single line of your domain code. Your business rules remain perfectly preserved. Now, to actually pull this off, the architecture relies on two golden rules. Rule 1, the domain layer has absolutely zero framework imports. If you open any domain file, you will not see a single mention of Ktor, JSON, or the exposed ORM. Rule 2, dependencies always point inward. The outer layers know all about the domain, but the domain knows absolutely nothing about the outer layers. It relies entirely on interfaces, basically forcing everything else to adapt to its rules. Section 2, bulletproofing the domain, value objects and typed IDs. Remember that nightmare runtime bug we talked about earlier? The solution is contrast. We need to completely ditch the anti-pattern of passing raw strings around and embrace the best practice of using typed IDs. By using Kotlin's @JVM inline value class for something like a user ID, the compiler treats it as a totally unique type, completely distinct from a checkpoint ID. It eliminates that entire category of bugs at compile time. And because it's inline, the compiler actually strips the wrapper away at runtime, meaning you get this massive safety net with literally zero runtime memory cost. It's a total win-win. But we definitely don't stop at IDs. We use private constructors and init blocks with require statements to enforce some seriously strict encapsulation. By making constructors private, we basically force all object creation to go through validated factory methods. So the really crucial point here is that an entity, let's say an observation, can never be instantiated with a blank description. An invalid object simply cannot exist in memory. The factory guarantees it every single time. All right, now when modeling state, you usually have to choose between enums and sealed classes. Enums are fantastic for simple fixed labels, like an observation being open, in progress, or resolved. But when your variants need to carry their own specific behaviors or completely unique data, enums fall way short. And that is exactly where Kotlin sealed classes step up and shine. Take our priority sealed class, for instance. Acute, high, normal, and low priorities aren't just arbitrary labels. They actually calculate deadlines differently. By defining an abstract method on the parent and letting each subclass override it, we're using polymorphism. And this brilliantly illustrates the open/close principle. If we need to add a brand new priority level later, we just add a new subclass. We don't have to go hunting down and modifying some massive, messy, centralized switch or when statement hidden somewhere deep in the codebase. What a relief, right? Section 3. Services and strategies. The orchestrators. Moving outward, our application services act as orchestrators, and they operate under some very strict rules. They exist solely to coordinate collaborators, like a password hasher or a token provider, connecting them via injected interfaces. They must always return pure domain entities, and most importantly, a service is not a procedural dumping ground for random logic. It's a clean, high-level coordinator that simply delegates the actual heavy lifting to specialized strategies.
Let's tie these heavy theoretical concepts back to reality by looking at exactly which files in our codebase build a perfectly solid foundation. Single responsibility. Our bcrypt password hasher does exactly one thing: hash passwords. Open closed. That's our priority sealed class we just talked about. Liskov substitution. The exposed user repository can seamlessly replace the user repository interface without breaking a sweat. Interface segregation. Our password hasher is small, focused, and totally separate from token generation. And dependency inversion, our app module dynamically injects these implementations so the high-level services never depend on low-level details. Section 4, the persistence boundary, safely crossing into data.
Now, to safely cross that boundary and actually talk to our SQLite database without breaking our inward dependency rule, we use the exposed ORM pattern. It requires exactly 3 files per table: a table schema object that defines the columns, a data access object, or DAO entity class that represents a single row, and an entity class companion to connect the two together. This perfectly maps our Kotlin code to our database tables. But here's the catch. We never, ever let those exposed DAO entities sneak into our pure domain. Instead, we use mappers. Think of mappers as the strict bouncers at the door of a really exclusive club. No ID, no entry. They take a database row and meticulously translate it into a pure domain entity, or vice versa. They're there to ensure that database-specific logic, SQL concepts, and weird framework quirks never leak inward and corrupt that pure VIP business logic.
Section 5, DTOs and the API, the outer shell.
Reaching the outermost layer of the application, let's trace the life of a single request to brilliantly illustrate how each specialized layer handles exactly one part of the flow. Step 1. Ktor receives an HTTP JSON payload from the chaos of the outside world. Step 2. A data transfer object, or DTO, parses that JSON and passes it to the domain's strict factory rules. Step 3. The application service takes over and orchestrates the workflow. Step 4. The exposed ORM mapper translates the final domain object and writes it safely to the database. It is a beautiful relay race where every layer does exactly one specialized job. Out here at the API boundary, we're relying heavily on standard RESTful HTTP methods, and it's absolutely critical to understand that our DTOs are just dumb JSON carriers. That's it. They are not domain entities. They have no rules and zero behavior of their own. They simply catch the data coming in via a post or put, or format the data going out via GET, mapping perfectly to standard web protocols, while our core logic remains hidden safely away. And really, that brings us to the core philosophy, the true thesis of this entire explainer. The domain is the part you spend the most thought on. It should not be tied to the framework du jour. Frameworks change, databases evolve, API protocols come and go. But well-protected, beautifully structured business logic, that endures. By peeling the onion and respecting these boundaries, you're building software that actually survives. So I want to leave you with a bit of a provocative question to chew on today. Take a hard look at your own projects. Which layer truly rules your codebase right now? Do your business rules dictate terms to the frameworks, or are the frameworks dictating terms to your code? Think about it. Thank you so much for joining me for this explainer. Keep learning, keep structuring those ideas clearly, and I will catch you in the next one.